Hello, everyone, and welcome to Considerations and Concerns for Platform Plugin Development. My name is Steve Grunwell. I'm a senior software engineer at Liquid Web and Nexcess. You can follow me on all the social networks that matter at Steve Grunwell, and if you're the kind of person who likes to have your own copy of the slides, you can grab those now at stevegrunwell.com/slides/platform-plugin. Don't worry if you don't grab them right now, though. I'll make sure to tweet them out. They'll also be linked to everywhere, and it's on the bottom of each and every slide. So I'd like to tell you a little bit about my day-to-day, what I do at work. I joined Liquid Web back in 2017 after working in agencies for most of my career up to that point. At Liquid Web, we acquired another hosting company called Nexcess in 2019 in order to rethink how we were handling managed applications. We already had a managed WordPress offering. We were the first to do managed WooCommerce, but there was more to be done. So since the Nexcess acquisition, I've been the lead developer on the Platform MU plugin. So this is a must-use plugin that runs across tens of thousands of sites. So internally, we refer to this whole platform as Nexcess Managed Applications, or MAPS. The MU plugin itself is installed automatically anytime the platform provisions a new WordPress, WooCommerce, or Store Builder site, and then it's automatically updated anytime we tag a new release. And I'll get into the details of that in a little bit. The general idea was, instead of pre-installing a bunch of plugins, which is what we had been doing before and what a lot of other hosts tend to do, we wanted to make sure that we could bundle things, that people knew that they were getting the Nexcess Managed Apps plugin, as opposed to just kind of pre-installing 10 plugins and hoping people figure out why we've added them. Then with this, we were able to intelligently turn the plugins on and off. So a feature that's specific to WooCommerce, for instance, is not going to be loading on a standard WordPress site. When it comes to building a plugin like this, there are a lot of unique challenges that we have to consider. First, every site is going to have its own combination of themes, of plugins, of different configurations. So how do we accommodate them all? Next, certain features might only be available on some higher plans, or again, may be specific to WooCommerce. So how do we toggle those off without releasing a dozen different versions? We don't want to have a bunch of variants of the plugin that we have to maintain. Third, the solution is going to impact tens of thousands of sites. So we need to take every reasonable measure to make sure that we're not breaking anything. And finally, one of the major advantages that we tout of our platform is performance. So we need to take extra care to make sure that we're not going to negatively impact that site performance by loading a bunch of unnecessary code, for instance, or performing really bad queries. Basically, we don't want to be the bottleneck. Now, this is not meant to be 45 minutes of me saying, hey, look at this thing I've built, because honestly, that doesn't help anybody except perhaps my ego. Instead, I wanted to show you how we've arrived where we have. Talk about what works and maybe what hasn't worked, some missteps we've made along the way, and then ultimately extract some lessons that you can use and take to your own plugins, regardless of the size. Now, a lot of these topics could and often are talks in and of themselves. So the README in the GitHub repo for these slides is just chock full of further reading, references, other talks, plenty of stuff to check out. So if I say something and you're kind of like, I don't know what that is, but it sounds very important, check the README file. There are going to be plenty of resources to help guide you along. Going back to this list of challenges, really, if your plugin is running on even a handful of sites, don't you face a lot of these same challenges? I mean, I said that these are challenges of building a platform-wide plugin, but really, any plugin of any reasonable scale is going to face a lot of these. Every site being different customers getting different features, having to deal with the fact that there are a lot of customers and not wanting to be the one holding the bag when the site turns out to be slow. So with that in mind, let's take a look at how we've structured the MU plugin, and we can dive into the architecture and the decisions that were made. Now we'll talk through each of these, but at a high level, this shows how they all connect. The green nexus-maps.php file, that's our bootstrap file. That's the file that lives in WP content/mu plugins and is responsible for kicking everything off. We're using an autoloader. So the bootstrap file first loads that, and then it initializes our dependency injection container. That's the big yellow square that includes a bunch of stuff inside. The DI container resolves our main plugin class, which then sets up everything else. The column on the right there in blue, the integrations, the WP CLI commands, and things like, well, let's start with our settings class. Now, the settings class acts as the brain of the plugin, and it can be injected anywhere it might be necessary. This gives us a centralized location for things like, is this a production site or is this a staging site? Getting the plan code, account ID, any sort of information that we might need. Now we're able to read these raw environmental details from Interworks, which is part of our platform's infrastructure. Then we do some light processing to get some really useful insights. So if it's a managed WooCommerce site, we want to do this, as opposed to if it's just a general managed application site. The settings object is often injected into our integrations, which are the basic building block of the plugin. It's a way for us to logically group this related functionality, and if it helps, you can think of them kind of like Jetpack's extensions. But rather than being turned off and on by the customer explicitly, in most cases, we're toggling them on based on the environment. So if you're on a certain plan, if you have a certain plugin installed, etc. We also have a number of PHP traits that we can apply to particular integrations if they require certain functionality. If you haven't worked with traits before, essentially, it's like taking PHP code, copying and pasting it between classes without necessarily having to inherit. I believe it came out in PHP 5.5, and it's extremely useful. Now, every integration includes a should load integration method, which is meant to decide, based on what I know now, should this integration be loaded. This method lets us boil everything down to, should I load this or not, true or false? Should this integration only be loaded on a staging site? Great. Does this plugin require that Jetpack be active? And if Jetpack's not there, we don't need to worry about it. Meanwhile, if this method returns false, we end up destroying the instance of the integration and we don't do anything further. We unset the variable so the garbage collector can clean it up. We remove it from the DI container, which we'll talk about in a second. We free up that memory so that we're not loading a bunch of unnecessary code and just keeping it around. Now, assuming the should load integration method returns true, the next step is the integration setup method, which is how we actually hook in the integration. This is usually registering actions and filters, but some integrations also need to load plugins that we bundle with the MU plugin, or otherwise start up different service classes and things. This is the main entry point, and basically anything we need it to do, it can. The plugin also includes a number of custom WP CLI commands, which are available to everybody. We don't do anything to hide them, but they all are under the NX Maps namespace, and they tend to be more for internal use. So for example, when a new site is first provisioned, the very last step in that chain is calling our WP NX Maps setup command. It does all of the things necessary to pre-configure a site. So it's setting a default permalink structure. So rather than $P equals the ID, we actually have like a pretty permalinks. It pre-installs any bundled premium plugins that might come with your plan. It's going to enable object caching, page caching, etc. The MU plugin also includes commands to help support do their jobs better. So things like flushing all of the caches, cleaning up after migrations from other hosts, or even creating self-destructing temporary support users. We have commands for all of these things, and they're bundled. They're right there within the MU plugin. If we come back out to this diagram, you'll see that we've covered the three rightmost items, those in blue. We did the settings class, we did integrations, we talked about WP CLI commands. But what is this big yellowish orange box around them? Well, this is our dependency injection container. If you haven't worked with dependency injection before, the DI container lets us define the dependencies for each integration, each service, etc., and then let the container recursively resolve them. This saves all of this unnecessary instantiation of objects, which in turn helps save memory. So for example, Instead of manually instantiating all of these objects when we're trying to get to some integration, we'll tell the container, hey, give me some integration, and it'll go through and resolve all of that class's dependencies and then give us the concrete instance of that class. It takes out a lot of code. We can also add all sorts of caching to this to help with performance. Now note that we don't use any sort of auto wiring within the MU plugin. If you have worked with a DI container in like a Laravel context before, you're probably used to like, oh, I type hit my dependencies, they all get resolved and everything's dandy. There is a performance hit in doing that. So again, in the interest of not being the performance bottleneck, we have made the decision to be explicit in our definitions. It makes it a little harder for developers, but way nicer for customers. So this is inside the container class. We have a get configuration method that returns a big array of classes mapped to closures that then return instances. So here we're saying that in order to build some integration, we need a settings instance as well as the some service class. The container then caches the results, so we're only instantiating each one of these objects once by default. It's kind of like a singleton, but it's way easier to work with, way easier to test, and way cooler. Now the plugin class, which was purple on the diagram, this is the main plugin class, and its sole purpose is to set everything else in motion. It has exactly one public method, Bootstrap, which is responsible for loading all of the integrations, including running their shouldLoad integration methods. It also defines constants and registers the WP-CLI commands. We'll see all of this in action in just a second. Because MU plugins don't get activated in the same way as a regular plugin, we need to define a single entry point. In our case, it's wp-content/mu plugins/nexusmaps.php. This is an abbreviated version of the Bootstrap file, with a few key things to note. First, we're wrapping the whole thing in a try-catch block, so if anything goes wrong, chances are we're not going to white screen a site, which is very important. Next, we create our single instance of the container, and then we use that to resolve the plugin class. What are its dependencies? Doesn't matter, because the container is taking care of it. Finally, we call the bootstrap method from earlier on the plugin class, which kicks everything else off. We're fully bootstrapped with our plugin in like 3 lines, which is pretty cool. Now, I mentioned earlier that we did auto loading, and you may have noticed in these examples a severe lack of require once statements littered throughout the code. That wasn't for the sake of brevity. Instead of loading every plugin file into memory on every request, we can take advantage of a little thing called autoloading. If you haven't used autoloading before, basically you're telling PHP how to resolve class names to files. So when a request is made to a class that PHP doesn't already know, it knows how to then find the file. So it'll just load it as it needs it. If you're using Composer, you can even generate the autoloader for you automatically, which is what we do in the MU plugin. The standard autoloading pattern these days is known as PSR4, where the file names need to match the class names and the namespace structure. So in this case, my company /my plugin /some class maps to source/someclass.php. Because we've told it to look in the source directory anytime it needs to find something in the my company /my plugin namespace. With our Composer-generated autoloader, we can replace all of those require once statements from earlier with a single call to the autoloader, and PHP will handle everything else from there. So when we go to instantiate these classes, it'll go, oh, I don't know the definition for that, let me look it up real quick, which is pretty handy. Now, one thing we ran into early on that bit us, and it's a really common pattern in WordPress plugins, but it will cause you so much pain if you're trying to use autoloaders and a DI container. It's treating class constructors like default methods. Let's take a look at an example. Anytime an instance of some class here gets instantiated, it registers hooks. So if you have multiple instances of some class, you're going to get multiple callbacks, which can lead to all sorts of issues. You're hitting an API multiple times, or you're saving data over and over to the database. Remember, in object-oriented programming, the constructor is meant to provide the instance with any dependencies. It's not meant as some default method call. A much better approach, then, would be to instantiate the class, then call the method. In our plugin class, that's going to be the bootstrap method. In our integrations, it's the setup method. It also makes the objects compatible with the DI container, since we're only bootstrapping the object when we mean to. Remember these? The architecture of the plugin helps address some of these. First, we're using namespaces to prevent us from conflicting with other code, so that kind of hits 1 and 3. We can selectively activate integrations based on the environment and destroy those that we don't need, so that's really kind of 2 and 4. Meanwhile, auto-loading and dependency injection make sure that we're not loading a ton of unnecessary code. Now, let's take a look at the build process and see how we get all of that code to all of those thousands of sites. And before we get into that, I want to tell you, in front of all of WordCamp, that it is absolutely fine to have a build step. There are a lot of WordPress developers who seem to have this idea in their heads that the plugin as it exists in GitHub must be built and ready to go at any time. Someone should be able to go, grab a zip file directly of master or whatever in GitHub, install it, and be good to go. So in order to accomplish this, they end up committing third-party dependencies. They have compiled CSS and JavaScript in there. And all of this just makes reviews a pain and invites merge conflicts. Now, this is probably conflated by the plugin SVN repos on WordPress.org, because those are meant for distribution, not for development. But please, let me tell you here, it is absolutely okay to have a build process for your plugin. We have one, WooCommerce has one, Jetpack has one, heck, even WordPress Core has been modernizing their build process. And there are a lot of great tools out there. Things like package managers, so Composer, NPM, Yarn, etc. We have build tools like Webpack and Laravel Mix. Remember that the tooling is there to help you produce the best outcome. So use whatever tools are going to help you the most, and then automate absolutely everything you can. We literally have a maps build Composer script that'll build out a production-ready zip file, which is the very same script that we run as part of our CI/CD pipeline. Now, continuous integration and delivery, or CI/CD, is a process that automatically runs all of these tests every time we push to GitHub. After all, if computers are good at one thing, it's taking a set of instructions and doing that same thing over and over and over again. So every time we push, our pipeline builds the plugin and runs all of our tests. As a result, we get consistent builds and know that our tests will be run under the same conditions every time. There's no, oops, I ran it in a different order. I forgot to run tests. Oh, my environment's not set up for testing. No excuses there. The pipeline handles it the same way every time. It's testing across multiple combinations of PHP and WordPress, and I don't have to lift a finger. All I do is push code. Now, when it comes time to prepare a release, the pipeline also calls that build script to generate the optimized production-ready zip file, but only after checking that dependencies are up to date and doing other sorts of pre-flight checks, because again, we've scripted this all out. It runs the same way every time, and if we do encounter an issue with it, we update the pipeline. We make sure a new check is added so the thing that got out before does not get out again. This just makes our software better. It lets us release more confidently, and it ultimately gives customers a more stable product. So what kind of tests do we run? I am talking about the CI/CD pipeline, and we have all of these tests, but if you know me, you know I'm big on automated testing. I've given talks multiple times, too many times maybe, on automated testing. And at this point, we're hovering around 1,000 unit and integration tests using the WP core testing framework for the MU plugin. If you're new to testing, I highly recommend checking out my talk, Confidently Testing WordPress, which again, I've linked to from the README file. But we're doing more than just running things through PHP unit. We have coding standards checks. So we're using PHP Code Sniffer and PHP Coding Standards Fixer to help make sure that whether I write the code or someone else writes the code, it's all going to look uniform because we're following the same standards. We also run compatibility checks, which are through PHP Code Sniffer. Everything that we write needs to be compatible with every version of PHP that we officially support on the platform. Additionally, everything that we're bundling, even if someone else wrote it, that also needs to be compatible. Now, in some cases, this even leads us to having to patch their code, which we have a way of doing through Composer, which is pretty cool. We perform static code analysis using PHP Stan. This analyzes the code without actually executing it and can help identify some weird things that maybe we wouldn't catch in code review. We have scripts to automatically check that all bundled dependencies are up to date. We do this before each and every release. These aren't automated tests, but we're also doing code review. Every change that goes into the MU plugin gets reviewed by at least one person on the team who didn't write it. And then finally, of course, manual testing. Sometimes you just have to roll up the sleeves, get in there, click around, and make sure that everything is working exactly as intended. One pain point we ran into early on was testing across multiple versions of PHP. We didn't want to abandon the customers who are still running dead versions of PHP, since it's technically on us because we have yet to fully remove those older versions of PHP. We don't have many customers running them, but we can't just pull the rug out from under them. But at the same time, we don't want to be stuck on ancient versions of PHP Unit. So to get around this, we are taking advantage of Symfony's PHP Unit Bridge component. PHP Unit Bridge lets us run the latest version of PHP Unit based on the PHP version. So if we're running something that's only compatible with PHP Unit 7, that's fine. We can run PHP Unit 7. If we're testing something that requires a higher version of PHP Unit, we can load that in. We also had to hack the core test suite just a little bit because it doesn't officially support PHP 8 yet. But as we're going to be rolling out PHP 8 very shortly, we need to make sure that we're able to test on that. So we're now running our test suite on PHP 5.6, all versions of PHP 7, so 7.0, 7.1, 7.2, 7.3, and 7.4, and PHP 8.0. Now, looking back at that list of challenges from earlier, we're handling differences between sites and toggling features based on the customer because, again, every site is going to be different and customers might get different features. We're using autoloading in the DI container to keep a small footprint, and we have a consistent way of building, exhaustively testing, and deploying across all of our customer sites. So I feel like we've hit all of these at this point, but there's still more that we can do around number 1. It's almost certain that unless you're building a plugin for a single site, you're going to have to tangle with some combination of themes, plugins, core, and PHP versions. People are going to have differences, and you need to be able to support that. So there are 2 concepts to keep in mind when we're dealing with something like this. First, it's important to embrace the idea of progressive enhancement. Now, the general idea of progressive enhancement, if you're not familiar with the term, is to build a solid baseline, something that will work in as many places as is reasonable. Then, as their configuration, as their environment, as their hardware, whatever allows, you start adding or improving upon features. That's the whole point of the should load integration method within the integrations. We remove it if we have no reason to load it, but more importantly, we only load it if we have reason to load it. Along with that, instead of backporting features to old versions of WordPress, check to see if those versions support the feature, and if so, then load it. So for example, there are some features that weren't available until PHP 5.4. So if a customer is still running PHP 5.2 on our platform, they just don't get that feature. We're not trying to backport everything. It's just, nope, you don't get it because it doesn't exist for you yet. Along with embracing progressive enhancement, it really helps if you define what your minimum supported versions will be. Now, this could be some combination of a PHP version, it could be a version of WordPress, it could even be a particular plugin version. But determine where you kind of draw that line and say, anything below this, use at your own risk. Furthermore, be ready to raise that minimum down the road. Just because you support PHP 5.6 right now doesn't mean you should be doing that 6 months from now. In the MU plugin, for instance, we won't load the MU plugin for customers running anything under WordPress 5.0. So 5.0 is kind of that baseline. If you're still running 4.9 because you wanted to avoid Gutenberg, instead of getting the MU plugin experience, you get a notice in WP Admin that basically says, hey, by the way, there are a bunch of features that you get on the platform that you're not taking advantage of right now because you're running an ancient version of WordPress. So please upgrade. Otherwise, you're just leaving features on the table. It tends to help gently push people, and we don't have to worry about testing back into the 4 series. Now, Finally, let's take a look at a few lessons that we've learned along the way. Now, first and foremost, when you start building something bigger than the typical WordPress plugin, it can be really tempting to just build everything like a web application, especially if that's kind of where you're comfortable. If you're a Laravel developer and you're told you need to build a WordPress plugin, you're probably going to try to build a Laravel application and just cram it into WordPress. And that doesn't work out super well. Remember that if you're building within WordPress, there are a lot of tools there for you already. The MU plugin, we add a lot. Between the dependency injection container, the auto loading, there's a lot that we add. But at its core, it's still a WordPress plugin. We're using actions and filters. We're not implementing our own system. We're working with options and user meta. We're registering settings pages using the settings API from WordPress. We're not trying to sidestep the WP REST API and creating our own thing, or reinventing the hook system or anything else that already exists and works well. Don't reinvent the wheel. Take advantage of what you have before you. Next, it's important to remember that customers have chosen us, but not necessarily all of the features we roll out. It's kind of the trade-off in managed hosting. I mean, we want to keep pushing new features, things that can help people, things that can improve performance, but not every customer is going to want all of our changes. So we do what we can to give customers a solid starting point. Things like full page caching, a Redis-backed object cache, and a performant theme, these are going to be installed, activated, configured out of the box. You spin up a new site, they're there so that you can have a solid foundation to build on. Meanwhile, if you're migrating over, or you've been building sites for years and you have a very particular set of plugins that you like to use on each and every site, we shouldn't be getting in your way. So the MU plugin actually includes some code to just deactivate integrations or features if you're running something else that already does the job. So along with good defaults, it's our responsibility as a host to get out of the way when the customer wants to make alternative options. Now, as I've said, a lot of the MU plugin is around optimizing sites for performance, for security, for making it easier for customers to use. But some of the features are decidedly kind of add-ons, nice to haves, things that might not be required for every site. So for example, we have the plugin installer. It's a page within WP Admin that has a curated list of both free and premium plugins. So you can install free ones from WordPress.org from this list, but you can also install and automatically license some of the premium plugins. We've made the partnerships, the deals, so that our customers have access to these just by the very virtue of being a Nexcess customer. This is really great for customers who run their own site and they want to take advantage of these premium plugins. But this can also be a liability for agencies who are trying to lock things down, who are saying, no, client, please don't go installing every plugin because it looks cool. So to this end, we provide filters to let developers disable these features if they choose. They can add one filter to another MU plugin or to the theme or whatever to say, yeah, no, we don't want this optional feature. Turn it off so my clients don't get confused. Because again, it's their choice. It's their site. We can give them a good starting point. We can help them along the way, but ultimately they should be in control. Then finally, when you're building, it's really important to keep an eye on the resources you're occupying by regularly measuring your plugin's performance. Now, there are multiple ways to do this, whether you're doing load testing, where you're seeing how traffic holds up by saying, okay, what does the server load look like when I have 10 concurrent users, 100 concurrent users, 1,000 concurrent users? You could also do profiling to determine the most expensive parts of your code, but testing performance should generally always follow this pattern. First, you want to get the current measurements. You need that baseline to know where you stand right now before you make your change. Next, you make your adjustments. This is where you go in and you say, could functional programming really speed things up here? Is this going to optimize the database, or is it just going to pull things down? This is where we actually experiment. Then we evaluate our results. We profile the application again, and we say, hey, We thought memory consumption would go down with this, but actually it added a second to the load time and increased memory usage by 50%. Maybe that idea wasn't as good as we thought it was. Then we can go back and we can repeat this process over and over again until we're satisfied. Now, in the slides README, I've included a link to a great talk by a developer named Kat Tien that really helped demystify performance testing for me. It was the first time that I saw K-cache grind and all of the colored boxes, and it was highly recommend checking it out. So that's all I have for you today. I want to thank you all so much for taking time out of your day to watch this talk. I hope you gained something out of it. And if you have any questions, again, I'm at Steve Grunwell on everything, and I would be happy to answer them. Thank you so much.